Good afternoon, colleagues. Good morning, depending on where you are at this time. And welcome to this particular webinar that we are pleased to host on behalf of the Compass project. So my name is Gerfas Opondo. I lead the team at the Environmental Compliance Institute, who are part of this project. And I will be your moderator for this particular session. And to kick us off, I'll briefly give an overview of the project, briefly talk about our organization, and also let you know why we are here today. And thereafter, I'll invite my colleagues, fellow panelists, to take us to the next items on the agenda. So briefly and quickly about the Environmental Compliance Institute, or ECI. We are a Nairobi-based or Kenya-based non-governmental organization with a mission to promote sustainable societies in Africa, and we do that by advancing good environmental governance as well as environmental rule of law. Our program areas cover 7 themes: climate and clean air, multilateral environmental agreements, waste and chemicals governance, sustainable cooling, transboundary cooperation on environmental compliance and enforcement, and finally, environmental regulatory training. So this project, the Compass project, falls under our climate and clean air program. So quickly going into the Clean Air Compass. This is a project basically to develop an affordable, scalable solution for air quality data management. And I'll be able to tell you a little more about it in the next slide. So as a background, air quality data or air pollution concentration data, especially in Africa, collected by multiple local sensors and other types of monitors, requires a data management system for data collection, storage, quality assurance, and analysis. And if you look at the landscape, especially across Africa, most organizations that measure air pollution need to purchase a commercial system or develop a custom-made data management system that comes with substantial duplication, because then different organizations have to develop their own standalone data management systems, as well as other barriers to efficient collection and use of air quality data for research, for public health, or other regulatory purposes. And for us in Africa, where financial resources especially, and sometimes technical capacity are a challenge, developing custom-made data management systems or even purchasing commercial versions sometimes becomes a problem. So the Clean Air Compass is basically a project that was launched in December of 2024. And it is funded by the Clean Air Fund. The lead organizations in this particular collaboration is the Natural Resource Defense Council, OpenAQ, as well as Sonoma Technology. So these are 3 organizations based in the US, but with operations and work across the globe. And The core partners for this particular project include organizations in Latin America, basically Aline Waira, representing Latin America. Then we have Clean Air Asia that represents the South, Southeast, as well as East Asia. And then for Africa, we have ourselves Environmental Compliance Institute that is leading the stakeholder engagement, especially across Africa. So with this project, we are in the process of developing the Clean Air Compass data management system. And this is a collaboratively developed, customizable open source data management system that is informed not only by African stakeholders, but also stakeholders from other parts of the world. And the intention is to help overcome duplication of effort, runaway costs of developing or even purchasing commercial systems, as well as avoiding the challenge of systems that are not built for purpose, and also the big challenge around data sharing. So when eventually this open source data management system is done and available, it should and is expected to help reduce duplication of efforts and therefore save time and money. We expect that this will help to remove barriers related to licensing fees, proprietary systems, as well as issues around technical capabilities. And this, in the end, should make sophisticated data management available to resource-limited organizations and communities across the globe. We also expect that this data management system will be scalable and will be able to support single-site community projects, as well as nationwide monitoring networks. So the next presenters will provide a little more detail about the current version of the data management system. But as we proceed with this particular meeting, I just want to invite you to use the Q&A box to put in your comments or questions, and we can try and tackle those towards the end of this when that session comes. And also feel free at the end of the session to reach out to us on email that will be typed in the chat box. You can also follow us and also get to know a little bit about our work on our socials. But for now, allow me then to invite the next presenter, who is going to be Jennifer De Winter. Jennifer De Winter is a senior project manager with Sonoma Technology, who are leading the technical development of the open source data management system under the Compass project. And she's going to grant us an overview of the open source data management system, what the current version looks like, and then, of course, provide you with an opportunity to give your feedback. So as you listen through the presentation, and I must say that this is a pre-recorded video of her presentation. Feel free to type in any questions or comments in the chat box as we proceed. So over to Jennifer. Thank you.
Hello, everyone. Thank you for your interest in the Compass Air Quality Data Management System, or DMS. Compass is the community of practice for air quality systems. a collaboration of air quality practitioners from around the world that was formed to share needs and learning and work together to accelerate progress for air quality management. The Compass Data System, or DMS, is a community-informed initiative to develop a customizable open-source data management system for air quality measurement data. You can learn more about Compass and the Open Source Data Management System project at cleanaircompass.org. My name is Jennifer DeWinter, and my organization, Spheros Environmental, is partnering with NRDC, OpenAQ, and Compass global and regional partners to develop the Compass Data System. Compass was formed with funding from the Clean Air Fund. Today I'll walk through the Compass Minimum Viable Product, or MVP, for a new open source data management system designed specifically for community air monitoring. And this work really is about bridging a gap many of you are familiar with, community groups collecting data but lacking accessible, scalable tools to manage, quality check, and share that data. We're aiming to build something that works across user types, from community organizations to state and local agencies. And today I'll cover where we are, what we've built so far, and how you can engage in testing. During 2025, the Compass network of core partners gathered stakeholder feedback through a series of workshops. The feedback was used to develop a system design plan to prioritize the features and functions needed for the initial version of the DMS. The first version, being built in 2025 and 2026, establishes the core architecture and essential features to demonstrate system functionality. We're not trying to build everything at once. We're building the core foundation first. That means getting data into the system, standardizing it, applying basic quality checks, and making it accessible with a simple interface to explore the data. And there's another important point, is that this whole project is intended to be open source. That means organizations can download it, modify it, and host it themselves. We're also considering a hosted option down the line for groups that don't want to manage infrastructure. And future phases will build on this with more advanced analytics, integrations, and automation. These priorities shown on the slide were driven directly by stakeholder input. First, supporting multiple data sources, because most air programs are not working with just one type of monitor or instrument. And because of that, standardization is critical, especially if you want to compare across devices or share data. We included basic QC checks and logging, so system users can understand data quality, not just visualize numbers. Then AQI calculation and averaging help translate raw data into something more actionable. And importantly, we included a simple dashboard and administrative tools because usability is just as important as functionality. You'll also see things like multilingual support and alerts, and these came directly from community user needs. At a high level, the system has two main functions: ingesting data and sharing it. The data system includes four major components: a data pipeline that gathers measurements and metadata from third-party data sources, such as air quality sensors and other instruments, standardizes the data, and calculates data averages and other metrics such as air quality index, or AQI. Then there's the database that stores the raw and processed data. There's an API that facilitates data visualizations, queries, and exports. And finally, there's the website that provides an interactive map, analysis tools, download capabilities, and administrative screens. On the ingestion side, we're currently supporting sources like Purple Air, OpenAQ, and Air Gradient. Data comes in at regular intervals, minute or hourly, and is stored along with metadata. We apply QC screening and calculate averages. Then on the output side, the system uses an API to feed data into a website. And this architecture is designed to be flexible, so additional data sources and outputs can be added over time. The front end is a browser-based interface with no specialized software required. The homepage gives context about the Compass project. And the map view shows recent measurements, and this is often what community users care about the most. The analytics page allows deeper exploration with time series, data comparisons, and QC review. And then there are administrative pages for configuring the system, devices, users, and QC rules. We've included filtering tools throughout so users can tailor what they see. And for the MVP, the goal is to balance simplicity with enough functionality for more advanced users. And now I'm going to switch over and show you the MVP in action. What I'll focus on is the end-to-end flow, how data comes in, how it's quality checked, and how users can actually interact with it. So when you first come to the Compass DMS MVP website, you see this landing page or home page. And this is the browser-based interface where no installation is required. From a user perspective, this is designed to be accessible whether you're a community group or a regulatory program. And the home page gives an overview of the Compass project. Organizations that adopt the data system can choose to customize the homepage for their organization or project. Now I'm going to jump straight into the data views. So from here, we will click Explore the Map. And this opens an interactive mapping application. One of the consistent priorities identified during stakeholder workshops was the need to visualize measurements from different instruments on a single map. So the Compass DMS includes this recent measurements dashboard to meet that need. And so this is the map view showing recent measurements. Each point represents a monitoring location. These could be low-cost sensors or other sources. And the goal is to be able to immediately see spatial patterns, which is often the first question people ask. What's happening in my area right now? So first we can toggle to show measurements and then select a parameter, and I'll pick PM 2.5. Now we're seeing recent PM 2.5 measurements across this region. Clicking into a location brings up recent data and summary information. You can immediately see spatial patterns, and this is meant to be quick and intuitive, especially for community users who may not want to dig through raw data sets. In addition to changing the parameter, you can filter by time window and device type, including OpenAQ, Purple Air, and Air Gradient at the moment. This becomes important for agencies managing multiple networks or community groups comparing locations. There's also an option to download the data in a CSV file. This was another key feature identified in our stakeholder workshops. So that's the quick situational awareness view, and now we'll move into analytics. So I'll click the Open Full Analytics button. This is where users can dig into the data more deeply. You can view time series, compare across devices, and look at the underlying data. So here's a time series view. This is where trends, spikes, and patterns become more visible. This is useful for both community interpretation and for more formal review. One of the things that you can do is overlay multiple monitors to compare performance or look at spatial differences. And this is especially useful when you have a mix of instrument types. So now we have a time series showing information from two different devices. One is a Purple Air and the other comes from OpenAQ. And you can see that the display readily graphed both device types on one plot. And down below the plot, we have a summary table showing all of the data values that were recorded during the time period that we've specified. We also incorporate basic QC indicators, so users aren't just seeing numbers, but have some context on data quality. And over time, we envision that this analytics page can be expanded to include more types of plots and statistical comparisons. Now I'd like to briefly show you the admin page. And on the back end, there are tools to configure devices, users, and QC roles. And this is relevant for organizations that are hosting and managing their own system and is critical for usability and scalability. So in the admin pages, we have devices, users, QC roles, data sources, CSV upload, and events. In particular, I'll just highlight that the CSV upload provides an option to upload your own data into the data system. All you have to do is pre-configure your device on the admin devices page, and then upload a simple file that includes the device ID, date time, and value. So at high level, what you're seeing is the full pipeline from ingesting data, applying QC, and making it accessible through a simple interface. And this is the MVP, so it's intentionally streamlined, but it establishes the foundation for more advanced features.
Thanks a lot for that presentation from Jennifer. And I trust that you've taken some notes and are putting in any questions or comments in the chat box. So as Jennifer says, this is the minimum viable product or MVP version of this DMS, and is currently out for testing across different institutions in different parts of the world. For Africa, Nairobi City County has been selected as a test organization. And one of the key reasons for this is that Nairobi City itself has recently made some great progress towards improving air quality monitoring, as well as having data in an open source format through a city-owned data management system. And therefore, in the next presentation, I am going to be inviting the representative on Nairobi City government, in particular, Mr. Maurice Kavai, who is the Deputy Director in charge of climate change, air quality, and air quality monitoring and the city, to kind of just give us an overview of the progress Nairobi has made in the last couple of years and months towards enabling air quality monitoring, as well as availability of data for public consumption and for decision and policy making purposes. So allow me to invite Mr. Kavai to make the next presentation.
Yes, thank you very much, Jerry, for having me, and thanks a lot for considering Nairobi for the next level of support. Nairobi has really made a lot of efforts, as you say, and therefore my presentation will just look at how we have been able to undertake the work of air quality monitoring in the city, as well as providing the same support to in terms of accessing the data to the public, as well as Nairobi residents to be able to make informed decisions when it comes to air quality. So my name is Maurice Kavai. I'm the Deputy Director for Climate Change and also air quality monitoring. I'll be looking forward to making a very brief presentation how the air quality looks like. So first of all, is just to appreciate the work being done by the city, especially Clean Air Fund, in terms of enabling Nairobi to come up with a city integrated data management system. Looking at how our portal works, we really look ahead into improving this public portal so that we can be able to enhance the issue of data visualization, ensure quality control, and integrate it as much as possible. Next slide. So air quality ecosystem really looks at capturing data from PM 2.5 and also some gases related parameters. So we use this data to be able to improve accountability, improve the cycle of visibility, and also ensure that the city can be able to track action when it comes to air quality issues. So one of the key drivers of this air quality management system is the fact that the city has been able to make a very tremendous effort in developing evidence-based policies. And one of them is the Nairobi Air Quality Action Plan, which we're in the process of implementing. So as we move towards ensuring that we continue to provide the public with evidence-based data, or rather decision making, we want to strengthen our air quality measurement. We want to ensure that we're able to provide quality data. We're able to reach as many people as possible. We want to ensure that there's a lot of coordinated sectoral enforcement and community action. Next slide. So the overview of how our air quality portal works. The portal is able to collect real-time data from sensor networks. And the sensors we have currently, which are actually in our website, is local sensors from EACO, which we have already been able to use data from them. But it is designed in such a way that it can be able to collect data from other sensors, such as Purple Air, OpenAQ, and also air gradient sensors. The system sensors feeds into a centralized cloud-based data management system, applies quality assurance and validation protocols, and publishes visual dashboards and downloadable datasets for public and institutional use. So our air quality data is collected from hybrid of network, including the BAM sensors and low-cost air quality devices. And this sensor data collects the data every 5 minutes. Then after that, the data goes for validation using statistical and spatial algorithms, averaging on the trade calculation using the Python data management processes. And then data is also able to be stored in timescale, for high resolution and also temporal tracking. Then after that, our team from the city is able to do quality controls, especially our county environment department. So looking at that, now the data is ready to be exported for use, and ready to be used by the public as well. Next slide. This is just a layered architecture on how we intend to work very closely with our partners to be able to promote the OpenAQ kind of data access. This is the current situation with our data processing. We have the sensor layer, we have data ingestion layer, we have the processing layer, where validation and calibration and quality control happens, as I had discussed in my earlier slide. Then we also have the storage layer, especially in our cloud database. And finally, we have the presentation layer, and which indicates how the public is able to visualize the data as well. Next slide. So in the event that we go ahead and integrate our data with other open data, what we'll be looking at, because the system we developed is open, we'll be looking at getting the APIs from the other sensors which are available, and then integrate that data into our platform, as well as linking that data with Nairobi climate and weather datasets. We intend also to look at how we can integrate traffic data and transport datasets for pollution source analysis, as well as looking ahead into integrating satellite-based datasets. By this, we'll also enable APIs for universities as well as researchers and civic innovators as well. Next slide. So how do we intend looking at what we have with our public portal? We want to ensure that we can be able to improve user experience and enhance the public portal to have that outlook that is modern, very interactive, integrated with GIS mapping. Have a portal that is mobile accessibility and inclusivity, provide mobile-friendly access and responsive design for people with disability. And this is very key because you might imagine people who have certain disabilities, including poor eyesight, how they cannot be able to integrate or they cannot be able to access that data. Then we'll also have the ability to look at other disabilities such as the deaf, maybe incorporate certain designs that can really reach this target group. Issues of multilingual support. I think normally we are using only English, but as a city, we want to believe that we can also be diverse. If this can also translate into use of the Swahili language, then this can also really help Nairobians in terms of air quality and other languages. I know we have diverse languages in the city of Nairobi, and we want to ensure that it reaches as many people as possible. So we're also looking at how it can also integrate automation, alert people when we have poor air quality issues, and events that are really triggering poor air quality in the city, and the customize dashboards, customize analytics dashboards that can be used by as many policymakers as possible. Give an example of what the governor was using sometimes 2 weeks ago in Madrid. You really explain the use of that dashboard to diverse audience, and Nairobi really scored high in that particular space. So another item which is also very key in terms of what we want to achieve is develop a predicability model for the city. By this, we intend to predict the air quality of tomorrow today. This is possible because we have quite a lot of data. Our monitoring stations have really exceeded the required time, that is 6 months, and therefore I think in this new initiative through the support of ECIs, OpenAQ and Sonoma, I think we can be able to really achieve that. Next slide. So some of the challenges and solutions we have envisioned as a city is inconsistent sensor calibration and maintenance. Whenever we introduce a new sensor, it has to be calibrated. And then there's the cost of maintaining the sensors is not easy because you have to physically go to where the sensors are located to be able to check any challenges with the operation. The other thing is about data gaps due to connectivity or power interruptions, and the limited interoperability between data sets. Cybersecurity and data privacy concerns, although we have not witnessed issues of threat on that particular space, but it's something which you need to be wary of. Then limited capacity for long-term system maintenance. I want to believe that this kind of support will be able to look at how the city can get long-term system maintenance, including even the data itself, so that we can avoid those data lapses when it comes to data gaps issues. So some of the recommended solutions which we are looking forward is to be able to standardize the calibration. Now we have done some particular work on this, but we need to keep on improving so that at least this kind of procedures are well documented, and at some point we can enhance this same knowledge to the public as well. The issues of backup, it is very key for us to be able to get that support so that we avoid that redundant communication. So standards, data standards, adopt open data standards and interoperable APIs, promote security protocols, strengthen cybersecurity protocols. And in this, we need to come up with what we call data sharing protocols as a city. Therefore, these are documentation which can really support our work. We need to continuously build the capacity of our technical staff through continuous technical capacity upgrading for them to be able to undertake data air quality data management, support without any gaps in the city as well. Next slide. So, what do we see as opportunities in this venture? One of them is to support evidence-based air quality policy, not only development but also implementation, enhance public awareness and citizen engagement, strengthen climate resilient and public health planning, enable regional and global air quality data collaboration, and position Nairobi as a leading African smart city for environmental monitoring. I think we have seen the president positioning Nairobi in that space by inviting the French government to spearhead that. So some of these things can really happen if Nairobi is able to position itself at the center of this discussion. Thank you. Last slide.
Thank you very much. Sorry.
Sorry, I have one final. So our next steps. We look at how we'll be able to pilot, test, and stakeholder feedback. Of course, we need to look at the various data providers, share with them and get their views. Refinement of the DMS platform. At the same time, expansion of sensor integration. Apart from the sensors which we have, the others which the city has procured, and we also want to integrate them in this new kind of development. We're also looking at improving the public-facing quality portal and formally our partnership with universities, agencies, and development partners. So thank you very much, Jerry, for having me in this discussion.
Thanks very much, Maurice, indeed, for that very insightful presentation about the great work that is happening within the city of Nairobi. Colleagues, this is also the kind of work that many other African cities are currently getting into from the east, west, north, and southern Africa. And Nairobi being a test city, for that matter, just kind of gets to represent what the situation is like or is developing into in many of our countries across Africa. But we really hope and look forward that when the open source DMS is up and running and available, that many African cities and institutions will be among the first adopters of this. Before, to get us moving into the next level, I want to invite Simon Kerr, who is a program officer at ECI, and who has in the past couple of months interacted with the Compass DMS and has interrogated certain aspects of it, and is going to share some of the insights and comments that he's been able to pick out of that. So welcome, Simon.
Okay. I hope everyone can hear me. So my name is Simon from the Environmental Compliance Institute. So I'll be talking about the open data management system from an African perspective. So this initiative is a global initiative, but what specific conditions that we have in Africa necessitate the existence of this platform, and what are the opportunities for scaling? So in Africa, we have unique challenges that, compared to other geographies, make us a special case for air quality management and mitigation. One of those is the complex nature of our emission inventories. A lot of geographies in Africa have challenges and difficulties. One, attributing the source of the different emissions. This is due to transboundary emissions and such kinds of issues. And we also have challenges attributing specific emissions to health outcomes. We also are predominantly in the continent relying on biomass for cooking, heating, and other home energy uses. And within these same geographies, we have predominantly second-hand imports for our vehicle fleets. In some jurisdictions, about 70 to 80% of the vehicles in the country are second-hand imports. Then we also have regulatory and institutional bottlenecks, some of which we'll talk about as I continue with the presentation. So this here is what I'd like to table as the roadmap for the developments in air quality monitoring on the African continent. So we've had quite a unique path, and we can categorize that into three categories, which I have here as air quality monitoring 1.0, 2.0, and 3.0. So we define air quality management 1.0 as the traditional air quality monitoring that we had, where it was primarily reference grid infrastructure, which more or less led to sparse monitoring due to the high upfront and maintenance cost of reference grid infrastructure. Then with the increased reliability of low-cost sensors, we've seen a shift into hybrid solutions that incorporate low-cost sensors, a dense network of low-cost sensors with a few strategically located reference grid monitors. This has allowed for the monitoring in the African continent to vastly shift to a point where we have a lot of high quality data streaming in. And the future, which is what I call air quality monitoring 3.0, transcends this hardware. So we have a software bottleneck, which is we have good, reliable data coming in from different streams. But one, the data is not standardized across the continent. And secondly, the accessibility of this data proves to be a challenge in a lot of situations. So we'll talk about this bottleneck. The software bottleneck isn't necessarily due to a lack of monitoring or a lack of sensors. As we've seen from the Nairobi City County presentation, a lot is happening in the monitoring space. A lot of data is coming in. This data, for this data to be translated into actionable insights, is where the software comes in. Next slide. So as I talk about low-cost sensors and how they've radically transformed monitoring in the continent, we still have to talk about the nuances of this low-cost hardware. They're not all perfect. One of some of the good attributes of these low-cost sensors is the resource efficiency. They require minimal space, low power consumption, and at times intermittent maintenance. They're also economically accessible as compared to purely reference grade monitors, which allows for dense hyperlocal networks that can give us good data across space and time. Some of the concerns include accuracy concerns. They are sometimes affected by variables including humidity, temperature, and they have limitations to exactly what they can measure. The reliability especially drops off when you're measuring particulate matter larger than 1 micrometer. There's also need for rigorous continuous calibration. As Mr. Kavai from Nairobi City County has informed us, they are constantly going through cycles of calibration and maintenance to ensure that the data still is what we call decision grade data that can be used to influence decisions. So this is where the open source data management systems come in. And here I provide a brief overview of the solutions that exist at the moment and the differences to an open source solution. So we have one of the solutions being employed across different African cities and institutions is proprietary data management systems. So a proprietary data management system is a system you purchase from an organization that deals with making data management systems, and you pay it like a subscription, more or less, depending on where you purchase it from. You're paying it per sensor or per user. Then we have custom-built or bespoke data management systems. These are data management systems that are built internally in the institution. So if it's a national government, they build their own system, or if it's a youth monitoring group, they build their own system. Whatever the institution is trying to achieve, they do all the development in-house. Then we have the open source data management system, which is free for all and accessible to anyone who might want to use it. So some of the differences come across in the economic feasibility of systems. Proprietary systems tend to have licensing fees which are high at times. Custom or internal systems, you have the cost of maintaining an internal developer to develop the system. Then open source systems are free to use, modify, and distribute. Then we have the argument about our data. Where does the data sit? With a lot of proprietary systems, the data sits in a server somewhere, most times outside of the continent. But with open source systems, we have full sovereignty of the data, and you can self-host the system. You can choose a hosting provider depending on the configuration that the institution is looking for. We also have the interoperability, which is Nairobi City County has sensors at the moment. If they want to import a new data management system, or if they want to upgrade the current data management system that they have, with a proprietary system, it might be difficult to do that since the systems are locked to specific brands that the companies work with. But with the open source data management system, the data is ingested from all types of sensors, cleaned up, calibrated, and can be shared on the platform. Then we also have the transparency of the algorithms that run these systems. With a system that you buy, that you purchase, you have very little control over what goes on in the back end of the system. But with an open source system, you can have a transparent system, peer reviewable, open to the public, where everyone can scrutinize the data, the manipulations that the data goes through. Very good for academic work. And lastly, we have scalability. So this is the system worked in Nairobi or the system worked in Kampala. Now we want to do it countrywide. How do we go about that? With proprietary systems, now you have to do the per sensor scaling or per seat scaling, gets quite expensive. Custom built internal systems, depending on how the system was designed, could handle it or could break under heavy loads of data. Then we have the open source data management system, which is highly scalable, and all you have to do is just import sensors in those different regions that you want to scale to. Yeah, so I wanted to briefly talk about what African cities are doing, what African institutions are doing that necessitates the need to move this data to an open source model. Nairobi City County, for as a case study, is institutionalizing data-driven policy and decision making through a lot of means, but three key instruments that I have here. One is the Nairobi City County Air Quality Action Plan, 2025 to 2029, spearheaded by the city county itself. Is a document that shows that the city is thinking about the future of air quality and steps that need to be taken to improve it. Then we have the city-owned monitoring network and public access portal, a sneak peek of which we've been shown by Mr. Kavai. And we have the Nairobi Air Quality Working Group as a blueprint for institutional collaboration. This particular working group brings together stakeholders from national government and county government, showing the commitment of all the parties involved into improving the air quality of the region. And last, but finally, I'd like to posit some of the opportunities that lie ahead of with open source data management systems. One is technological leapfrogging. So leapfrogging is a term we use when, for example, in technology systems, we can jump all the hurdles that another party has encountered simply by observing and adopting the latest technologies. So with open data management systems, there's open sharing, there's learnings from each other, and we can radically improve the pace at which we improve our monitoring networks. Then we have empowering governments for interagency harmonization and regional policy expansions. Since the system is uniform, collaboration across agencies, across countries, across regions becomes easier. And finally, empowering citizen science and grassroots change makers for community-led engagement. Because an open system that can be trusted by the people is one of the most powerful vehicles of instituting change in air quality management. Thank you.
Thank you very much, Simon, for those insights. And now I would like to move to the next session, which is going to be a very quick needs assessment that is going to be run through some Mentimeter questions. And then we shall open it for some discussions, comments from the floor as we move forward. So my colleague Paul will lead us in that session.
Okay, good afternoon, everyone. Just give me 1 second. Good afternoon, everyone. I hope you're all well. So currently I will take you through the needs assessment session. And in this session, we'll be talking about different questions to be answered around licensing, data protection, barriers, and also the features to make this better as well. So I will give you 2 minutes to please join the Menti meter using the code shown on your screen, which is 79351841. Please join the Mentimeter, and I will also share on the chat box a link as well, just in case for anyone who might need it as well. So yeah, just 2 minutes. Thank you. Perfect. Let's keep that number then. I see 11 people so far. Just clarification as well. It's going to be menti.com. As shown right here. Join at menti.com. Use the code 79351841. Okay, perfect. So we're at 20, which is a good number, so we can proceed. So the first question is, based on the demonstration, please rate the system on the following user interface metrics. So the first one is the dashboard interface is easy to use and predictable, while the other one is instructions for adding new data inputs are clear. I'll give you another 2 minutes as well to respond. And there's also the QR code on the right side of the screen as well. I hope you can be able to all see it. And that's good. Also, a quick reminder, please put in your questions within the Q&A box so that now we can be able to track them efficiently for the discussion as well, which will be after this. Okay, 13 people have to respond, and the numbers are increasing, which is very, very good. Perfect. Just in case anyone did get the question, based on the demonstration, please rate the system on the following user interface metrics. The dashboard interface is easy to use and predictable, or instructions for adding new data inputs are clear. Do you strongly agree with them, or do you strongly disagree with them? Next. Okay. So that was the first question. So for the next one, it's going to be rank the following barriers to future use of this open source platform from most to least critical. The first option is data protection and security concern, lack of in-house technical expertise, licensing and self-hosting uncertainties, or integration limitations with existing proprietary systems. The question is, rank the following barriers to future use of this open source platform from most to least critical. Data protection and security concerns, lack of in-house technical expertise, integration limitations with existing proprietary systems, or licensing and self-hosting uncertainties. You can see data protection and security concerns is leading out of one person who responded. I'm going to give you 2 minutes as well for this, please. Question is, rank the following barriers to future use of this open source platform from most to least critical. Data protection and security concerns, integration limitations with the existing proprietary systems, lack of in-house technical expertise, or licensing and self-hosting uncertainties. And see 5 people have responded out of 31. Come on, guys. I know you're there. See, data protection and security concerns and integration limitations are leading. Okay. Now there's a deviation. Okay. 18 people have responded. I believe I can now move to the next. The next question is, what features would you need added to the beta version to make it more meaningful and useful? Please type it in onto the text box. The question is, what features would you need added to the beta version to make it more meaningful and useful? Please type it in onto the text box. Let's see, comparing different geographies. And AI assistance, okay. Comparing different countries and recommendations options. Not sure. Very interesting. I know there's something in your mind, so just whatever it is, please type it out. Any feature that you think that will be useful to the beta version will be appreciated. Public interface for feedback mechanisms, metadata to features surrounding conditions, integrate the air quality data with other weather parameters and physical metadata. That's a good one. Comparative local and regional outputs. Okay. User training guideline. Good. Expanding the analytics section, AI and ML, especially for predictability. A prediction model, offline accessibility. Okay. Well, that is 11 out of 33 have responded. The question is, what features would you need added to the beta version to make it more meaningful and useful? Mobile device compatibility, a feature that can summarize and create summaries in PDF. Language options, okay. Could you please specify what language options? Integrated feedback loops, user onboarding and guidance. Nice. That's 13 out of 34. Can give a few more seconds before we move to the next question. Climate services analytics for farmers, stroke interface with meteorological departments. Clear instructions inside each feature. Okay. Ten more seconds. Integrated data for air quality at county level. Okay. Unified data integration and language as well. Again. Thank you guys for the feedback. This is really helpful so that now we can be blown out early to the beta version and thereby make it more meaningful and useful. So keep them coming in. So I think we can now move on to the next question. So the next question is, what specific policy decision or action would you take if provided with accurate air quality data? What specific policy decision or action would you take if provided with accurate air quality data? Please type it in onto the text box. And also a quick reminder, please, if you do have any Q&A or other any questions, please type them in the Q&A box and we'll be able to answer them at the end of this specific session. Thank you. The question is, what specific policy decision or action would you take if provided with accurate air quality data? Please type it in onto the text box. Ban extended vehicle idling. Okay. Realign budget support. Keep them coming in. Advocacy through communities for improved environments. Someone has actually suggested they can help legislators draft laws or regulations that can help reduce bad air quality that can be useful for governance. Okay. Please send us an email as well, and we can see how to move forward with that. Our email is in the chat box, communications@tciafrica.org. Create low emission zones. Okay, that's the same also with the next one, establish low emission zones. Enforce temporary emission controls. Okay. Strategic information, education, and communication on air quality data to enhance public education and awareness policy on access to and utilization of air quality data. Incentivize less polluting vehicles, industries, etc. Next one is appropriate social behavior change. Communication messaging would be better targeted with accurate information with the attendant policy changes to enforce the changes required. Nice. That's fine. 10 out of 34 have responded. Okay. Question is, what specific policy decision or action would you take if provided with accurate air quality data? Please keep on typing in your suggestions. Establish trigger thresholds that automatically activate interventions, such as traffic restriction on highly polluted corridors, encourage use of electric motors to reduce contaminated air, informed decisions on objectives and activities pertaining to your air quality management plans. Okay. Keep them coming in, please. Establish public health protection methods. Okay. Clean fuel initiatives, targeted health advisories, stricter emission standards, infrastructure prioritization. Okay. Can see some more suggestions. Guide urban planning and clean energy investment decisions. Issue public health alerts. Identify air quality hotspots. Okay. That's 15 out of 34 responded. Can give 1 minute for the others to respond. What specific policy decision or action would you take if provided with accurate air quality data? What specific policy decision or action would you take if provided with accurate air quality data? Recommendations for greening initiatives, regulate industrial activities. Okay. Thank you very much for the suggestions. This is very helpful, especially since this is a stakeholder feedback workshop. So thank you very much for all the feedback, and we really value your feedback as well, because it will really help us with the next version of this data management system. Integrate cleaner in schools, conversion of plastics to energy, policy on data quality and security. Okay. Transition to e-mobility, establish low emission zones around schools and hospitals to protect the vulnerable. Okay. Mm-hmm. 18 people have responded. 10 more seconds. Okay. Compile emission inventories. So we can move to the next question. Do you have any feedback, questions, or comments for us? Do you have any feedback, questions, or comments for us? Please type it onto the text box. The last question is, do you have any feedback, questions, or comments for us? Please type it in onto the text box. Quick reminder, also, if anyone has any questions, please also check it onto the Q&A box and we shall be able to answer all your questions during the session after this specific presentation. Very insightful. Thank you very much. This is an excellent concept whose time has come. Simplification must be key without losing the integral aspects of the system, given that the pros heavily outweigh the cons as presented. Thank you. Person missed the user interface demo, if there was any. Apologies for joining a bit late, shareable. Yes, we will share the webinar recording as soon as possible within the coming days, so that now you can be able to watch the user interface demo. Does this project have a plan for upscaling the project results to other cities in Africa? Thank you for that. We shall be able to answer that later on. Interesting initiative. More info on how we can get involved. Okay, thank you for that. Air quality is a huge topic that requires strong partnership. Are you open for more engagement, especially on media advocacy? Yes, we are more open for engagement. So please email us at communications@eciafrica.org and we shall be able now to engage with you further on that. And that includes anyone else who is interested with engaging with us for any partnership or any kind of engagement also for this. Add clearer instructions so users understand features quickly. Thank you. Have physical or practical training of the system operation in the stakeholder centers, stroke hubs in the communicate where community members, including school kids, can learn. Okay. In case anyone missed our email, I will send it again in a few onto the chat. There we go. So that is our email, communications@eciafrica.org on the chat. I have shared the email for convenience and official communication. You're most welcome. A great initiative and look forward for the engagement. Please share the webinar. Yes, we will share the webinar recording and we do look forward for the engagements. And for that, please do email us and we shall be able now to engage further with you. Okay. Focus on making core features fully reliable before adding extras. Okay, this is well noted. Can give 1 more minute and then we can move to the next part of our webinar. Also, another reminder, please type in any questions that you have in the Q&A box and we shall be able to answer them. Improve navigation so it's easier to move around. Thank you. Question is, do you have any feedback, questions, or comments for us? Please type it in onto the text box. 10 more seconds. Okay. Thank you very much for all your feedback and suggestions and everything. The Mentimeter will be open for a few more hours just in case anyone might have missed this. So please answer the questions and please give us any feedback or suggestions so that now we can be able to know how to be able to improve this beta version into a more meaningful and useful interface, or rather platform for everyone. So thank you very much for this. So for now, we shall move now on to the next part, which concerns the Q&A. And in this Q&A session, I will read them out and I will also hand them over to the respective people to be able to answer them. So we have a question from Haitham Wingro, whereby he asks, does the system has built-in front-end Q&As through QC protocols, or is it dependent on the user's own data management objectives? The other question is, how does the Compass DMS fit into the Nairobi City County Air Quality Data Portal? Any interoperability between the two systems? Nairobi has low-cost air quality sensors and are more applicable in monitoring PM2.5 and PM10. How does the system fit in our context, in especially some of the gas emissions? And the third question from Joshua is, the system allows for uploading of CSV files with data. How do you ensure that data quality checks and controls if any person can upload data? Also, a follow-up question from Joshua Gidinji is, this is to the director. You talked about integration of the platform and other open data systems. Do you have plans to integrate to the Kenya Health Information System, KHIS, given that the WHO estimates 19,000 deaths in a year in Kenya attributable to poor air quality? So I will thereby now hand it over to the respective people within my team to be able to answer these questions. Thank you.
Thank you very much, Paul, for taking us through that session. So I will take perhaps just 2 questions and then hand it over to Maurice and Simon also to jump in. So the first question, I think, is from Haitham. And my response to that is that the system that the Clean Air Compass project is building is an open source system that should be free to use and should be customizable. And therefore, users, depending on the use cases that you may want to use this for, should be able to download and to modify and to customize on need basis. There was a question that was also dropped during the Mentimeter session, and it was about the possibility of us upscaling this project to other cities in Africa. And the answer is yes, that when this open source data management system is done, available, and ready to use, then it should be open and available to different users in different parts of the world, including African cities, to simply download, customize, and use as they wish. Of course, other items, for example, like data loading and sharing protocols and all that will then have to be agreed and as we move forward, depending on what the different users prefer. Yeah, so I want to hand over to Maurice and maybe to Simon. Maurice, if you're there.
Yeah, Paul, thank you. Thank you, Jerry. I might have missed the question because of some network connectivity issues, but I had something to do with whether the system in Nairobi can be able to host other other sensors. I don't know whether that was the question, Paul.
Sorry.
If you don't mind,
Question
maybe you
two.
can.
Okay, so question two concerns.
Yes.
Yeah. The question from Joshua Githenji is, Nairobi has low-cost air quality sensors and are more applicable in monitoring PM2.5 and PM10. How does the system fit in our context, in especially some of the gas emissions?
Oh, okay, yes. What we have not been able to have is the APIs for the gas sensors. But when we were developing that system, we had put that one into consideration. So we only need
Yeah,
to
so
get
Boris seems to have some connectivity issues from his location. Yeah, but I'll pass it on to Simon, maybe to attempt at that question, even as Maurice comes back.
Okay, so I'll take two of these questions. One was about the interoperability with, especially, for example, Nairobi's existing system. So this system is interoperable with all types of sensors. And there was also a question about integrating it with other data sets, like for example, national health data sets. With this being an open system, you can download the system. If you have the technical expertise, which a lot of our departments at least have technical officers, you can customize the system and run a local instance that links with all the different types of data sources that are important to your city, because different cities, different institutions have different data needs. And you can also customize how you show this data to the public, how you share this data with the research organizations. So that can all be done. You download the system, customize it, run a local instance. There was also another question on what parameters the system is able to accept. As long as it comes from an air quality monitoring sensor, you can measure parameters beyond particulate matter. So we can have beyond PM 2.5 and other particulate matter. We can also measure sulfur oxides, nitrogen oxides, volatile organic compounds, and all different types of emissions. You just have to customize it to your needs and sensors and the data sets that you have. Thank you.
Thank you very much, colleagues. I don't know if there are any other questions that may be still hanging out there. If there are, please just drop them in the Q&A and we'll attempt to do that. Otherwise, I would like perhaps to just let you in terms of what next steps for the Compass project looks like. So going forward, the piloting of the prototype is continuing and will continue through to September of 2026. So different feedback sessions are happening and will continue to happen in different parts of the globe. This being just one for us for Africa. Next, there is expectation that the next iteration of the prototype will be developed after September. So this should be in place at least by October of 2026. And this will include development of documentation as well as training materials to support users. So I saw in one of the comments in Mentimeter that training for users might be useful. Yeah, so development of training materials to support users will be happening, and this should be ready again by around October of this year. And the expectation is that the final version of the DMS will be ready for launch by November of this year, after which now different users should be able to download, customize, and interact with the system in whatever use cases that they expect. So from our end at ECI, we will continue to pick your feedback. As Paul did mention earlier on, we shall be sharing the recording from this particular webinar, which includes the demonstration of the current version. So feel free, even after this event, to share any feedback with us on email, because your feedback is extremely important, and this will help the technical team that is behind the development of this to incorporate every aspects of your needs into this particular version. Also, as Paul did say, the Mentimeter will be open, I think, for a couple more hours. So feel free to just jump in and provide any feedback on that. Otherwise, if there are no other questions or comments, perhaps I would just open it up to Simon and then Maurice to have a minute each for some closing thoughts before we call it a day. We have done extremely well, so we might just give you back 30 minutes of your time on this. And thanks very much for your active participation. So Simon, 1 minute, and then Maurice, 1 minute, and then I'll wrap it up.
Yeah, thank you. Thank you very much, everyone, for your engaged participation. Feedback is very, very insightful, and it will help us in the next version of the system. Mine is just a call to action. Air quality management starts with so different tools keep popping up every day. I urge each and every one of us to interact with the tools at our disposal. We have now an open data management system coming up, but even as the data management system is being developed for each of our respective jurisdictions, maybe you're from Nairobi, maybe you're from Kampala, there's a local data management system in a lot of African capital cities. Let's interact with it. Let's do advocacy work. Let's change our air for the people who can't do it. We have vulnerable communities among us that can't advocate for themselves. And it's up to the people in this room to do that so that we can see change. Thank you.
Thank you very much, Simon. Last but not least, Maurice.
Yeah, thank you, Jerry. Thanks a lot for having me. Mine is also a call for action, and I would say that we cannot wait any longer. When an opportunity presents itself, we should be quick to jump in. And I want to reiterate the words of Simon that we need to be very alert when it comes to seizing these opportunities. So from the city of Nairobi, we are hands-on, and we are ready to jump into this collaboration and improve our public portal. Thank you very much once again for having me, and to the participants, I wish you the best. Thank you.
Thank you very much, colleagues, and thank you very much to all the participants from across Africa and other parts of the world. it's been a pleasure having you on this webinar, and your feedback has been extremely useful. Of course, we expect that more will continue coming even on email. So thank you very much. Look out for any future communication very soon regarding the progress of development of the DMS. And we hope that eventually this is something that works for us, works for Africa, and works for the world. Thank you very much, and have a good afternoon or a good morning, wherever you are.